In 2019, a photograph taken from space stopped the internet completely. It showed what appeared to be a massive waterfall on the floor of the ocean. Millions of people shared it, news outlets covered it worldwide, and scientists were asked one question: is this real? Because if this is not a real underwater waterfall, then what is? And the answer to that question leads somewhere nobody expected. The real underwater waterfalls, the ones science has actually documented, make every waterfall on the surface of this planet look like a garden hose. This is the Denmark Strait. From the surface, it looks like any other stretch of cold northern ocean. But 600 meters below where you are looking, the largest waterfall on Earth has been running every single second for millions of years. 3.5 kilometers tall, moving 2,000 times more water than Niagara Falls, completely invisible from the surface, and almost nobody knows it exists. In this video, we show you exactly what it is, what it does to this planet, and what happens if it ever stops. Let us start with the image that started this conversation. What you are looking at is the southwestern coast of Mauritius, a small island nation in the Indian Ocean. And what it appears to show is a massive waterfall cascading off the edge of the ocean floor into an abyss below. The image spread because it looked impossible. A waterfall at the bottom of the ocean. And for millions of people who shared it, that was exactly what they believed they were seeing. But here is what is actually happening. Sand and silt deposits on Mauritius's underwater plateau are carried by ocean currents toward the drop-off edge and cascade downward along the slope, creating, from directly above, the perfect visual illusion of a waterfall. Up close, underwater, it looks nothing like a waterfall. It is sand drifting slowly along a slope, carried by a gentle current following gravity. The illusion only works from directly above. The Mauritius image is not a hoax. It is a genuine natural phenomenon photographed from space that creates a genuine optical illusion. But it is not a waterfall. And the reason that matters is this: the real underwater waterfalls, built not from sand but from water itself, are so far beyond this image in scale and significance that they deserve to be understood on their own terms. To understand what a real underwater waterfall is, you need to understand one thing about water that most people never learn in school. Temperature changes its density completely. Warm water is less dense, it rises. Cold water is more dense, it sinks. And salt water is denser than fresh water. In the ocean, these two forces, temperature and salinity, control everything. In the North Atlantic near the Arctic, surface water becomes so cold in winter that it becomes denser than the water below it, and it sinks. Enormous volumes of cold, dense water descending from the surface to the ocean floor. And when that water reaches an underwater ridge, it does what any water does when it reaches a cliff. It falls. This is what an underwater waterfall actually is. Dense, cold water flowing over the edge of a submerged ridge and cascading downward into the deeper basin on the other side. Scientists call them cataracts, and one of them is in a category entirely its own. To understand the scale of what is waiting in the Denmark Strait, you first need to stand at the edge of one of these ridges and look down. Because nothing about the surface of the ocean above prepares you for what is happening below it. The Denmark Strait sits between Greenland and Iceland. Below its surface, a submerged ridge, the Denmark Strait Sill, runs across the strait at 600 meters depth. On one side, cold Arctic water accumulates. On the other, the ocean floor drops to 3,500 meters. The ridge is the cliff, and the water goes over it every single second. The Denmark Strait, 300 kilometers wide. From the surface, it looks like any other stretch of cold northern ocean. Gray water, cold wind, overcast sky. Nothing about the surface gives any indication of what is happening 600 meters below it. Below the surface, the Denmark Strait sill, a submerged ridge, runs across the strait at 600 meters depth. On the Greenland side, cold, dense Arctic water accumulates constantly. On the other side, the ocean floor drops to 3,500 meters. The ridge is the only thing between them. And the water goes over it, continuously, every second of every day, without pause, without variation, without stopping. The Denmark Strait Cataract, the largest waterfall on Earth. 3.5 kilometers tall, 5 million cubic meters of water per second. That is over 2,000 times the flow of Niagara Falls, every single second. By every measurement that defines a waterfall, this is the largest one on Earth. If you tried to fill a container the size of Lake Superior using the Denmark Strait Cataract, 8 months. Using Niagara Falls, over 1,400 years. The same container, right now, running silently 600 meters below the surface of the North Atlantic. The water that goes over that ridge does not stop falling for 3.5 kilometers, descending through total darkness under crushing pressure in water near freezing until it reaches the floor of the deep basin below. At the base, the cold, dense water spreads across the deep basin floor and begins flowing southward, a slow, cold current moving along the bottom of the Atlantic. And this is where the story stops being about scale and starts being about something that affects every person on this planet. There is a second underwater waterfall, smaller than the Denmark Strait Cataract, but no less extraordinary. It sits at the Strait of Gibraltar, the narrow corridor just 14 kilometers wide, connecting the Mediterranean Sea to the Atlantic Ocean. The Mediterranean loses more water to evaporation than it receives from rivers and rainfall. Atlantic water flows in at the surface to compensate. But the water left behind becomes saltier and denser and flows out through the bottom of the strait into the Atlantic. Inside the strait, two currents run simultaneously in opposite directions. Atlantic water flowing in at the surface, dense Mediterranean water flowing out at depth. Two rivers in the same channel, moving opposite ways. Where the Mediterranean outflow meets the Atlantic slope, it falls. A second underwater waterfall cascading down the continental slope, documented and studied by oceanographers for decades. But what makes this waterfall remarkable is what happens after it falls. As the Mediterranean water descends and mixes with Atlantic water, its density adjusts, until at 1,000 meters depth, it exactly matches the surrounding water. It stops sinking. It spreads horizontally outward across the Atlantic at that exact depth. Scientists can track that Mediterranean water mass thousands of kilometers out into the Atlantic, identified by its specific temperature and salinity signature. A waterfall with a trail stretching across an entire ocean. The Denmark Strait Cataract is not just the largest waterfall on Earth. It is one of the primary engines driving the global ocean circulation system. The enormous conveyor belt of water that moves heat around the entire planet and regulates the climate of every continent on Earth. The Gulf Stream carries heat from the tropics toward Europe, giving Western Europe its mild climate. London sits at the same latitude as parts of Canada that experience brutal winters. The reason London does not is the Gulf Stream. And the Gulf Stream keeps flowing because cold, dense water sinks in the North Atlantic, pulling warm surface water northward to replace it. The Denmark Strait Cataract is the drain that makes it all work. Remove the Gulf Stream and Europe gets colder, much colder. The same cities, the same coastlines, but winters that would make current European infrastructure completely unworkable. And the Gulf Stream stays running because the Denmark Strait Cataract keeps pulling cold water out of the surface layer and sending it to the ocean floor. The effects of a weakening conveyor belt extend far beyond Europe. Research has documented that a slowdown would simultaneously cool northwestern Europe, raise sea levels along the US East Coast, and disrupt rainfall patterns across the Amazon and the Sahel region of Africa. All of it connected. All of it driven by whether cold, dense water keeps sinking in the North Atlantic. All of it connected to the Denmark Strait cataract, running silently 600 meters below the surface right now. An invisible engine keeping the climate of an entire hemisphere stable. And it has been doing this since before our species existed. Here is the uncomfortable part of this story. The Denmark Strait cataract runs because cold, dense water forms in the Arctic and sinks. That process depends on the Arctic being cold enough, and the Arctic is warming approximately 4 times faster than the global average. Warming does 2 things that threaten the cataract. Warmer water is less dense, harder to sink, and melting Arctic ice releases enormous volumes of fresh water into the ocean, diluting the surface layer, reducing its salinity, making it even less likely to sink. Both effects pushing in the same direction. Research published in the journal Nature has indicated that the Atlantic meridional overturning circulation has already weakened significantly, sitting at its weakest point in over a millennium. The debate among scientists is not whether it is slowing. The debate is how fast and what the tipping point looks like. Some models suggest gradual weakening over centuries, giving ecosystems time to adapt. Others suggest a tipping point, a threshold beyond which the slowdown becomes self-reinforcing and rapid. The direction is not uncertain, the timeline is, and the Denmark Strait cataract sits at the center of that uncertainty. There are scientists who spend their entire careers monitoring the Denmark Strait, measuring whether the cataract is still running at full strength, whether the deep water formation is still occurring, whether the engine of the global conveyor belt is still turning. Not glamorous work, but arguably some of the most important measurements being taken anywhere on Earth right now. We have sent spacecraft to the edge of the solar system. We have mapped the surface of Mars in more detail than many regions of our own planet. And yet, the largest waterfall on Earth was hidden 600 meters below the surface of the North Atlantic, completely unknown until the middle of the 20th century. We know the surface of Mars better than we know the floor of our own ocean. Less than 20% of the largest habitat on the planet we were born on has been meaningfully explored. The Denmark Strait cataract was hiding in plain sight, in one of the most studied bodies of water on Earth, and we found it less than 100 years ago. The ocean covers 71% of this planet. It regulates our climate, drives our weather, and moderates our temperature. And the systems that make it do those things are largely invisible to us, running in the dark, under the pressure, in the cold, completely out of sight. Somewhere below the surface of the Denmark Strait right now, 600 meters down, in the dark and the cold and the silence, the largest waterfall on Earth is running. It has been running since before our species existed. It is keeping Europe warm. It is driving the ocean circulation that regulates the climate of every continent. And it is doing all of this completely invisibly, in a darkness so complete that no human eye has ever directly seen it. The ocean is not a passive backdrop to life on this planet. It is the engine. The Denmark Strait cataract is one of the pistons keeping that engine running. And we are only just beginning to understand what happens if it stops. This is mysterious nature, and this is just the surface.